Hello, let us see how to solve this particular problem. So basically what is given is there are two chips, chip 1, chip 2. This is basically a memory chip which has address bits, and then chip select is based on some other address bits, and the higher bytes of these address bits are not used. So we need to find out among these addresses which address range is not allowed using this configuration. So now what happens is, what we have to understand here is basically uh, if we address directly, example A0 to A7, so that is a byte, so you will have address starting from 00 to FF directly. So all the address range from 00 to FF will be represented by this, right? And then similarly 00FF, and based on the data you send to this, that will be stored in this particular memory chip. But the problem here is this particular chip is selected by using other address bits. Okay, so this is nothing but a chip select, using which the chip will be enabled. Okay, so now what happens is, because A8 and A9 are common, when particular configuration of A8 and A9 are given, the memory might not be able to be accessed. So we have to find out which memory address is not suitable in this configuration. So for that, what we have to do is, basically we have to have a address configuration of how it is arranged. A0 to A7. Okay, A0 to A7 is straight away addressable. That means there will be, the minimum address will be 0, the maximum address will end with 1111, right? And then there is this A8, A9 bits which are given from chip select. Now let us take scenario 1. Okay, scenario 1. Okay, so now A8, A9, and then A10, A11, right? And we have A10 to A15, but these are not used anyway. We need not bother about them at all. They could be 11FF or whatever could be the configuration. Now in this scenario, A10, A11 are also don't care, because they could be anything. So let us assume they are XX whatever. Okay, either it be 0011. The major problem is with A8 and A9. Now if you select the chip, if you see the chip 1 select scenario, A8 should be high and then A9 should be low, such that this chip will be selected. So similarly for the higher nibble. And when now see the scenario 2, okay, everything remains the same, A0 to A7, and then A8, A9, A10, A11 if you see. So again here the minimum value will be 0, the maximum value will be 1, right? And then this is don't care, A10 to 11 as we discussed. Here A9 and A10 will be reverse of this. That means A9 will be 1, A8 will be 0. Why we are having 1 and 0 in scenario is, for this chip selected to be high, for this chip to be selected, this AND gate should give a output of 1. If this need to be 1, this need to be 1, this need to be 1. So if this need to be 1, A9 should be directly 1. But if this need to be 1, A8 should be 0, so that the negation will be 1. So that's why A8 will be 0 here, A9 will be 1, such that both are 1s and the output of AND gate is 1 and the chip select shall be done. Similar explanation holds for this chip 1 chip select as well. So that's why we have put 1 0. Okay, which means in any scenario, for these addresses to hold properly, the A8 and A9 should be complement of each other, right, in any address range. So now let us start looking at each and every address range. So A0 to A7, suppose as these are 8 bits, this comes as 0 0, and then this is what the next byte is what we have to determine, and then this is 1 1, and the next byte is what we have to determine. Similar, if you go to these addresses, leave this ff, so this is one ff, right, instead of one ff. So if you eliminate this and take only this 1 and 2, that's what we have to take, right? That's what the variable is here. So if you take the first scenario, 1 is nothing but 0 0 0 1, right? 2 is nothing but 0 0 1 0. If you see, this is A8 and this is A9. So A8 is in one scenario, A8 and this one are always complement of each other. That is what it is here, right? A8 A8 bar, and then A9. A9 in one address it is 0 and the other address it is 1. So they are complement of each other. That means both the chips get selected in this scenario. Okay. Now, so this address range holds good for both the chips. That's what is required, but we have to find out which doesn't hold good actually. So now in this scenario it is 5 and 6. So if you take 5, 5 is nothing but 0 1 0 1, right? 240 241 2, 6 is nothing but 0 1 1 0. So here also A8, A9 are complement of each other. That means both the chips get selected, right? Now take 9 and A. 9 is nothing but 1001. A is nothing but 1010. Again here if you see A9, A8. So this address in addresses A8 and N complement of each other. So both the chips can get selected. Now the next one is 8 and here 8 and 9. So 8 is nothing but 1000, right? And then 9 is nothing but 1009. Here if you see, this itself fails because both the inputs cannot be 0 for the address to be selected. None of the chips get selected in this scenario. There is nothing like A8 and A9 0 in any case. A8 and A9, if you see, either of the memory addresses or the address range A8 and A9 are always complement of each other. In either maximum case or minimum case, it is 0 1, this is 1 0. So here 0 0 and this is 0 1. This address is okay because A8 and A9 are complement of each other. There will be some other address range, but when it is 0 0, there is no address that will be selected because the chip select will be 0 because the output of AND gate will be 0. With A 0 and 0, A8 will be 0, A9 will be 1. The output of AND gate is 0, so the chip select is 0. This chip doesn't select. Similarly, A9 is 1, A9 is 0 here, and A8 is 0 means this will be 1. That means this is 0, and again this chip doesn't get selected. So F8, particularly F800, is not a valid address to select either of the chips to write to these memories. So see, the ultimate aim is to write to these memories. So with F800, it is not at all possible to write to these memories.